For today's lesson, you're going to be learning about slopes of parallel and perpendicular lines, and this is lesson 2-4. So the first thing we need to do is a little bit of a slope review. You guys learned a lot about slope last year in Algebra 1. You learned how to find slope from a graph, from 2 points, from an equation, how to plot a line using slope. All of that stuff you covered last year. And of course, you probably remember some of it, but not all of it. So we're going to review just a little bit real quick on the stuff that you learned last year. And then we'll get into what you need to know for geometry. So the first thing that we want to just remember is slope on a graph. So that's what you practiced with on Delta Math when you were doing your rise and your run. So just a reminder here, remember a slope has a rise over a run. So just in this example, a rough sketch, we're going to say we're going up 3 and to the right 4. And so you remember that slope is m. We use the variable m to represent slope, and it is rise over run, also known as the change in y over the change in x. So you may remember delta y over delta x, so the change in the y value over the change in the x value, which also in this case we're going to say is 3 over 4. So those are different ways that you have seen to represent slope. And then the other way, the slope formula, I'm going to write here, and you may recognize it when you see it, but we know that the slope formula is y2 minus y1 over x2 minus x1. That should be a 2. So that's slope formula, and that is what I want to remind you of today. We're going to be using slope formula today, and that's just subtracting your y's and subtracting your x's. That's how I want you to think of it. Don't get distracted by your subscripts here and think that it looks complicated. And remember, it's just subtracting your y's and subtracting your x's. So we have slope on a graph, and then we have slope from points. So let's look at those points. Let's do an example here. If you have a set of points such as -2, 5, and 6, -1, you can find the slope from those 2 points without graphing it. So let me remind you, just like when we did the midpoint formula, and we labeled our x's and our y's, and then we plugged them in. So I'm going to subtract my y's here. That's going to be -1 minus 5, and then I'm going to subtract my x's here. So that's going to be 6 minus -2, and then I'm going to do my calculation. So what would -1 minus 5 be? That would give me -6. What is 6 minus -2? That would give me +8. And I would simplify that. What would that simplify to? -3 over 4. And that would be my slope. So that's finding slope from 2 points. That is something from last year. So this may look familiar to you, but you might have needed a little refresher. So again, that's just doing some integer operations. So I'd like to give you just one to try to see how you remember this type of problem. So find the slope for me between these 2 points. -11, -3, and -6, 7. So see if you can find the slope between those 2 points on your own. All right, so what did you get for your answer? What you should have gotten was 2. If you didn't get 2, I'm going to put my work here real quick so that you can see how I got that. The mistake that I most often see is forgetting to do this double negative here. So it's 7 minus negative 3. You can't just do 7 minus 3 because that's a different problem. So that double negative really makes it actually, an addition problem. So that becomes 10 over 5, and 10 divided by 5 is 2. So that's how I get my slope. So how does this apply to geometry? So this is an Algebra 1 concept, but we need to use our knowledge of slope to solve geometric problems. So I'm going to put our new information down here, and that's going to talk about parallel lines and perpendicular lines, which is a geometry topic. Before I do get into parallel lines and perpendicular lines, I want to remind you real quick of something. So I want you to remember what a vertical line is. Remember, this is a vertical line. And then I want you to remember what a horizontal line is. So we have a horizontal line. You have to remember what the difference between those two. Again, this is from Algebra 1, but I want to remind you of this. So we have a vertical line, we have a horizontal line. Why do I want to remind you of that? I want you to remember what the slope of a vertical line and horizontal line are, because that is important. So for a vertical line, you have an undefined slope. Okay, how does that look like numerically? Remember, we can't divide by 0 in math. So if you ever end up with a 0 in your denominator, that is undefined. Okay, and then a horizontal line has a slope of 0. So your slope equals 0. How does that look? That is when the 0 is on top. So if you were to have m equals 0 over 5, then your slope is 0. So see the difference here. If it's a 0 in the denominator, that's undefined. That's a vertical line. If it's a 0 in the numerator, that equals 0, and that's a horizontal line. So there's just no slope to this line. It is 0. Okay, so that's just a reminder from Algebra 1. So let me jump to now our geometric concepts and how we're going to use slopes. So we're going to talk about parallel lines and perpendicular lines. So I'm going to just draw a line here. And we're going to start with parallel lines. So we know what parallel lines are. We know the symbol for parallel lines is 2 parallel lines. And here's what we want to know about them. So your job to know is that their slopes are the same. So parallel lines have the same slopes. So if I have these 2 lines, their slopes are the same. That is the new content for you. Okay, this is what we're adding to our knowledge of slope. Parallel lines have the same slope. Their slopes are the same. So if I were to have these 2 lines, if I were to find the slope with whatever method, either slope triangle or using the points, they would have the exact same slope. Okay, so that's new knowledge. Now, what about perpendicular lines? Okay, perpendicular lines. What type of relationship do their slopes have? So the symbol for perpendicular, the pair of perpendicular lines. Remember, they form a 90-degree angle when they intersect. So their slopes, they have a special relationship. So perpendicular lines here, notice it's a vertical line and a horizontal line. And their slopes they're not the same. They are negative reciprocals. So that is an important word to know. Negative reciprocals, what does that mean? So you have heard the word reciprocal before, and of course you've heard the word negative before, but what does that mean when we put them together? So let's look at that so that we know exactly what negative reciprocals are. Okay, so negative reciprocals. I'm going to put that here. We know what a negative number is. Do we know what a reciprocal is? What do you think a reciprocal is? So a reciprocal basically just means flipping the fraction, and negative means the opposite sign. So how we want to remember this is opposite sign and flip. That's all you have to do. You change the sign and flip it. Opposite sign and flip. So you just take your fraction that you're going to have. So let me show you an example. If you have a slope that's 3/4, the negative reciprocal of that is flip it and make it negative. So it's going to be negative 4/3. That's all. Okay, so it doesn't take a lot of work to figure that out, but you have to know what to do. So we flip it, the 4/3, and then we just make it the opposite sign. So since this was positive, we make it negative. Let's look at some different types. So let's say you have the number 2. How do we flip that? Well, every whole number really has a 1 underneath it, so this would become negative 1/2. Okay? If it's already negative, so say we have negative 8/7, then it becomes positive. Okay, so opposite sign. So opposite would make it a positive, and flip it would make it a 7/8. Okay? Now, the negative reciprocal of, say, 0. So basically, if you have a horizontal line, the line perpendicular to that, this is kind of a special case, would be undefined. I'm just going to abbreviate that. All right, so those are all negative reciprocals. And let's go to some examples. Let's apply all of these to some problems. Okay, so I'm going to look at some examples here. So what we're just going to focus on today is from points, how to tell if the lines are parallel and perpendicular. Our next lesson tomorrow will involve equations of lines, but for today we're just going to look at the points. So what you're going to do is use slope to determine if a pair of lines are perpendicular or parallel. So I'm going to put the instructions here. Use slope to determine if lines AB and CD are parallel. I'm just going to use the symbols. Parallel, perpendicular, or neither. So maybe they have no relationship. So basically we're going to find our slopes. We're going to see, okay, are they the same? Are they negative reciprocals, or do they have no relationship and they're not parallel or perpendicular? So let's start with our first set of points here. I have negative 2, 3. I have 2, 6. So that's my first line, AB. And then for line CD, I have negative 1, 0. And I have 3, 3. So I'm going to determine if this line is parallel to this line, or is it perpendicular, or is it nothing? Neither. So I have to use the slope formula, and I have to find the slope of these two lines. So I'm going to start over here with AB. I'm going to subtract my y's and subtract my x's. So I'm going to do 6 minus 3 over 2 minus negative 2. Okay, what does that give me? 6 minus 3 is 3. 2 minus negative 2 is 4. So that's my slope for AB. Let me find my slope for CD. So 3, these are just simple integer operation problems. So 3 minus 0, and then 3 minus negative 1. Okay. So what does that give me? 3 minus 0 is 3. 3 minus negative 1 is 4. So would you look at that? They are the same. So then your job is to say, okay, I know that parallel lines have the same slope. These lines have the same slope, so they are parallel. Okay, so we would say parallel. Okay, let's look at a second example. And we're going to have the first set of points. 0, 2. B is 5, 4. C is 1, 8. And D is 3, 3. Okay, so let's first figure out the slope for AB, and then we'll figure out the slope for CD. So for line AB, again, I'm subtracting my y's and subtracting my x's. That's it. So I'm going to do 4 minus 2, those are my y values, over 5 minus 0. So 4 minus 2 is 2, and 5 minus 0 is 5. So that's my first slope. Let's find my next one. I'm just going to go ahead and box it in. So now for CD, 3 minus 8, that's my y values, over 3 minus 1. So 3 minus 8 gives me negative 5, and 3 minus 1 gives me 2. So let's look at my slopes and see how they compare. Well, they're not the same, but look, they're negative reciprocal. So 2/5, you flip it, it's 5 over 2, and then it's negative. So it's the opposite sign. So these lines are perpendicular. Okay, let's look at one more example. over 3. So we have A is negative 1/8. B is 2/6. C is negative 1/2. And D is 3/3. So again, let's start off with AB first. So what is 6 minus 8? And what is 2 minus negative 1? What does that give you? That gives you negative 2 over 3. So that's my first slope. Let's look at CD. So I've got 3 minus 2 over 3 minus negative 1. 3 minus 2 gives me 1, and 3 minus negative 1 gives me 4. Okay, you take a look at them. Most people probably then panic and think, oh, they're not parallel, or they're not the same, they're not negative reciprocals, I must have done something wrong. Sure, go back and check, but it might be the case that they are actually neither. So in this case, we would say neither, which is a possibility. If, say, you were doing a test question or something and it only said identify parallel or perpendicular and you did get something that was neither, it would be a good idea to go back and check your work. But in this case, neither is one of our answer choices, so we would say neither. And that is all that we're going to cover for today's lesson. Tomorrow, we will look at equations, y-intercept, or slope-intercept form, y equals mx plus b, standard form. We'll look at those tomorrow. So that's all for today.